Welcome to This Explainer. Today, we're diving straight into a fascinating linguistic mystery. It's a puzzle that actually holds the master key to bringing major African languages into the generative AI revolution. If you've been watching the explosive growth of AI lately, you know it's incredibly hungry for data. But what happens when that data is, well, a little messy, informal, full of hidden traps that completely trip up these algorithms? Let's figure it out.
Okay, imagine this. You type out a simple text about a really tasty meal you just had, only for an AI translator to completely misunderstand you and confidently claim you bought that food on credit. Unless you're putting your dinner on a literal payment plan, that sounds like a bizarre, highly specific glitch, right? But the crazy thing is, this exact scenario is playing out right now for millions of people.
And this brilliantly illustrates our core problem. Take the Hausa phrase, abincin bashi dadadi, which means the food is not delicious. But if you just drop a single space and a tiny hook on the letter D, it becomes abincin bashi dadadi, and that translates to food bought on credit is delicious. So just a missing space and a missing little hook shifts the entire semantic meaning. It completely breaks natural language processing tools.
So today we're going on a journey to see how researchers actually solve this. We're going to cover 1. AI's African language blind spot, 2. The anatomy of a typo, 3. The chicken and egg problem, 4. The transformer model showdown, and 5. The downstream ripple effect. All right, jumping right into Section 1, AI's African language blind spot and the sheer scale of the problem.
To put this into perspective, we're talking about approximately 80 million Hausa speakers, mostly across West Africa. It's a crucial lingua franca. People use it constantly for intergroup communication and regional integration. Yet, despite having this massive speaker base and a really rich linguistic history, it is still significantly under-resourced in the digital world.
The main villain in our story is what researchers call orthographic anomalies. Basically, that's just a fancy term for inconsistent spelling, spacing, and writing variations in digital texts. For Hausa, this usually means replacing native characters with standard English consonants. And these informal digital writing errors, they act like this invisible barrier, totally preventing modern AI systems from understanding the data.
Which brings us to Section 2, the anatomy of a typo, exploring what these digital errors actually look like.
When we communicate online, we all kind of take the path of least resistance, right? Because standard English keyboards are everywhere, Hausa speakers naturally just use them. But that leads to dropped hooked characters, so they end up swapping the specialized Hausa ba or da for a standard ba or da. It also leads to randomly removing spaces between words or duplicating characters. Now, for humans, these workarounds are easy enough to understand in context. But for an algorithm trying to learn the language, it's complete chaos.
Let me show you another visceral example of how this plays out. Swapping literally one hooked letter introduces total noise into the data. The phrase "wannan yata che" means "this is my daughter," but if you type it without the hook on the igek, it becomes "wannan yata che," which means "this is my elder sister." This sends an AI model completely off the rails. If you're building an AI translator, feeding it this kind of confusing training data is an absolute disaster. So, moving to Section 3, the chicken and egg problem of creating a dataset to actually fix this.
Here's the thing. The researchers faced a massive, classic methodological hurdle. You need a data set of errors to train the AI to recognize and fix them, right? But that data set just doesn't exist in official texts. Official Hausa texts like Wikipedia or news articles, they're mostly perfectly clean. And you absolutely cannot train an AI to fix social media typos if you don't have a massive library of those exact typos to teach it with.
Their solution? Honestly, it was brilliant. They built a synthetic dataset. First, they collected over 400,000 clean, official Hausa sentences. Then, they calculated the exact mathematical human error rates found in real social media data, specifically from Twitter, and they deliberately injected those exact human-like typos into the clean text. So they basically created the perfect training ground, a noisy to clean pairing, to teach the AI how to reverse that synthetic damage.
Now let's look at Section 4, the transformer model showdown, where they put the models to the test.
What is super fascinating here is the sheer difference in size between the top-performing models. We're looking at a blue score, which basically measures how accurately the model corrected the text back to its clean state. The massive 8 billion parameter NATLS model scored incredibly high at 0.886. But check out the model right below it, the M2M 100. It scored 0.853. That is remarkably close. It's a true David versus Goliath outcome in the tech world.
This highly efficient 418 million parameter model basically went toe-to-toe with an 8 billion parameter giant. It's a massive win for efficiency. It proves that smart pre-training, because the M2M100 was trained on many-to-many multilingual translations and the right architecture, can completely trump raw size. You just don't always need the biggest, most expensive model to get state-of-the-art results.
Finally, Section 5, the downstream ripple effect and the real-world impact of all this.
To make sure this text correction actually works in the wild, researchers tested it against a really diverse set of out-of-domain genres. They didn't just test it on Wikipedia. They looked at everything from popular science to argumentative texts to literary works. It proved the model's versatility across entirely different types of writing. And you can see the ripple effect of clean data so clearly when we look at named entity recognition, which is basically how well an AI identifies specific names, places, and organizations. When the text has typos, the AI's accuracy absolutely tanks to a score of just 0.19. But simply processing that exact same text through the correction model first, it nearly doubles the AI's accuracy to 0.37. Cleaning the data first literally makes the AI significantly smarter. We see this exact same leap in improvement in downstream machine translation tasks across all the major platforms. Whether you're looking at Google Translate, NLB 200, or GPT 5.1, the results are crystal clear. Automatically correcting the Hausa text from noisy to clean consistently yielded much higher scores across the board, which means drastically better, more accurate English translations for everyone.
This incredible academic achievement goes way, way beyond just building a better spell checker. As the researchers noted, this work places Hausa firmly on the global AI research map. It provides the absolute vital framework needed to ensure millions of African voices aren't left behind by the algorithms of tomorrow. By fixing this foundational layer of data, we unlock smarter chatbots, better search engines, and radically improved digital education platforms.
As we wrap up this explainer, I want you to really think about this final question. What other global languages are waiting to be unlocked by this exact methodology? Consider how many other low-resource languages out there could take their rightful place in the AI era using this very same synthetic data technique. The blueprint is here. Now it's time to scale it. Thank you so much for joining me on this journey into the mechanics of language and AI. I really hope this sparked your curiosity.